Calculus is a game of strategy and perception. It can be played on any size of board. The only important thing is that on the perimeter of that board, there are two regions that are black and two regions that are white. The stones that are placed can be any shape as well. We are going to use circular stones in this demonstration, but you can use real pebbles. This is a completed game. In this game, white has won because white has managed to connect up their two perimeter regions. The game starts by black sliding in a rock. Then white slides in a rock. Keep on alternating back and forth until we reach a point, for example like this, where it looks like black is just about to win the game. But remember, black has to slide in a rock, not place it in. So black can't do this without bumping other pieces. Instead of sliding in a new rock, black can move an existing rock. So here we see that black is sliding this rock into place and wins the game by connecting up black's two regions. White would have to be sleeping for something like that to happen. Much more likely, you're going to end up with a situation like this, where there's a region. Who owns that region? Is it black or white? To figure that out, you count the stones on the perimeter. In this case, it's 3-2 in favor of black, so black owns that region. Now black can connect and win the game. What are the rules for creating a region? Here, white wants to create a region. Can they do it? You look at the perimeter, you count the number of white stones, the number of black stones. If they are not equal, that's a legal move. So that's acceptable, and we color it white. Here, black is in a similar situation. Black wants to make this move here, but whenever we count the stones on the perimeter, we find out that both black and white have got 6 stones. So that is illegal. Black cannot make that move. The perimeter of the game board can also be part of the region that you're making. So in this case, we count the number of black stones, number of white stones in the perimeter. Again, 3-2 in favor of black, so that is fine. We call that a black region. We paint it black. Do we also have to ask about this region? No. We count the number of transition points. In this case, in that region, we have 3 of those transition points, so that region we don't even have to look at. We only look at regions that have got 2 or fewer of those transition points. Midway through a game, you're likely to end up with a lot of regions. You need to know one extra rule about moving existing pieces. So instead of sliding in a new piece, if you want to slide an old piece, it's not always possible. In this case, it's possible because that stone is not connected to a perimeter of a region. But here, that is an illegal move because that black stone is already taken up, defining a region that has already been colored white or black. So that is not an acceptable move. The game ends when both players decide to pass. In this situation, it looks like black is about to win. They've connected side to side. But not so fast. White looks at this piece and realizes that it's not part of a perimeter, so it can be moved, and they move it to here. And now there's nothing that black can do to stop white connecting side to side. White has won this game. Now let's look at a sample game. And we see that white has won. Enjoy.